Welcome to this tutorial on how to set up the Planetary Processing multiplayer SDK in Godot. Let's start by opening the project manager and creating a new project. The new project will need access to the Planetary Processing SDK. Create a new folder within the Res folder and name it Add-ons. Open a terminal inside Add-ons by right-clicking the folder and selecting Open in Terminal. Paste in the following git clone command and press Enter to download the SDK. This command can be found in our Quickstart documentation. To install the plugin, go to the project settings and in the Plugins tab, enable the Planetary Processing plugin. Then create a new scene and save it as main. We will be using a 3D node and code examples in this tutorial, but the plugin can also be used for 2D games. To implement the SDK, you'll need to add a pp root node as the direct child of the scene's root node. This node will pass player information to and from the server. The game ID parameter selects which game to connect to. It can be found on the Planetary Processing website in the Games section of the dashboard. The plugin has some C# scripting, so we need to create a C# solution and add a reference to that code using the CS_proj button in the pp root node. If you prefer to reference it manually, open the CS_proj file and insert the planetary reference to the C# sdk.dll in the item group section. Note the CS_proj file might not appear right away in the Godot editor, but should be accessible from your computer's file explorer. In the project settings, set our main scene as the main starting scene. Now create a new scene to act as our player. To the root of this new scene, add the pp entity node as a child. This will mark it as an entity, which will make it visible to the game server. Make sure it has the type player. We're also going to give it a cube mesh to make it visible to us. Note that the mesh on its own is purely visual, so the player will not collide with anything. As you're working, make sure to save often, since scenes like the player scene will be referenced in the code of some scripts later. Finally, add a camera node to the player to let us follow the main character around. Position it in front or behind the player for first or third person views. Next, we'll make some actual entities to populate our world. Entities are the backbone of planetary processing. Each object and creature in the world, including players, are entities. Create a cat scene in the same way that we created our player scene. It also needs a pp entity node and its defined type as cat. We'll be using a sphere mesh to represent our cat. To connect to the demo game server, we need 3 types of entities: cats, trees, and other players. Entity types are defined by the names of Lua files inside the server-side demo code. We'll be looking at these entity Lua files later in the video. The trees and other players are created in the same way as the cat and the main player character. The main character is distinct from the rest of the entities because, although it has a pp entity node, it will have to handle inputs from the client-side gamer and send them to the server. Other players, despite being player-controlled, can be treated like NPC entities, since from the client-side game perspective, they are both controlled exclusively by signals from the server. However, the other player also uses the type definition player. To finish off our entities, we need to sync them with the server. To do this, we need to add a script to each entity. This script will be handling entity movement, receiving coordinates from the server, and updating their position in the game engine. Return to our cat scene and give the root node a new script. All the code in this tutorial will be available in the Godot Quickstart documentation on the Planetary Processing website. In the ready function of your script, connect to the signal from the pp entity node and use it to position your entity using coordinates from the server. whenever that server entity moves or changes. Make sure each entity except the main player character has this script on their scene's root node. To spawn all these entities and players into the world, add a script to the root node of your main scene. This script will listen for spawning and despawning signals from the server. Start by making variables for the node itself, and wants to load in the player and the entity scenes. Place the entity scene variables, except the player scene, in a reference map. In the ready function of your script, assign the pp root node variable, and start listening for signals. These signals trigger 3 functions: player creation, entity spawning, and both of their removal. The player creation function loads the scene, checks for the pp entity node, and then adds the player instance at a specific location. The entity spawning function does the same, but uses the entity reference map to match the entity type with the correct scene, before creating an instance. The removal function uses the entity ID which all players and entities possess to selectively remove them. All this code so far is reacting to signals from the server, but to receive all these signals in the first place, we need to establish a connection. At the bottom of the ready function, call the pp root node's authenticate player function. This function has 2 parameters, for the player's username and their password. All these can be left blank for an anonymous connection. We are going to leave them blank, but we will have to warn our game server about this before we can connect, since anonymous authentication is off by default. We want to use this connection to send inputs from our player to the server. To set up inputs in Godot, open Project Settings and select the Input Map tab. Here you can name and add specific actions. We are going to set up a simple WASD movement for our player. Add each action and use the plus symbol to bind it to a keyboard input. We need a script to interpret these inputs and send them to the server. For the most part, this is a normal movement script, and the only difference is that these movements need to be sent to the server as well. Add a new script to the player root node of the player scene. Remember, all the Godot code for this tutorial can be found in our Quickstart documentation. Start by making variables for the pp root node and speed. Use the process function to get the inputs every frame and simplify them into a directional vector. Then multiply them by a speed and the frame lag time. Use the pp root node's message function to send the movements to the server. Most things which happen in your multiplayer game will require inputs to be sent to the server and for the server to update the client with the results. To make sure everything stays in sync, it helps to run multiple client connections while testing. To do this, select Customize Run Instances from the Debug toolbar and enable as many game instances as you would like. With everything now set up on the client side, open up your game on the Planetary Processing website. Remember that we use anonymous empty strings in our connection parameters, so update your game settings to allow anonymous authentication. If you want to test with the username and password instead, go to the Player Management section and create a player, then update the connection parameters. Launch your game from the dashboard. The preloaded server-side demo code will start to run, and you can observe your game world from the game dashboard map. The map shows you the location of all loaded entities, as well as how many there are of each type. Since we have our player entities and scripts prepared, we can also run our Godot game to join the world. You can now see both players in our game world. As you move around, the world will generate chunks around you, as if you're on a treadmill. Chunks currently not in use or without an entity chunk loader will despawn to save on resources. We can make a few more client-side alterations to improve our game, so that we aren't just looking at shapeless grey blobs. In our main scene, we can make a floor, using a simple Node 3D node and give it a plain mesh. The floor isn't an entity as defined by our server-side demo code, so it doesn't need its own scene or a pp entity node. We are going to give our game client some more colour. Rather than changing the colour of each of our meshes using scripting, we're going to create a very basic backdrop scene using coloured lights on a black background. To To do this, we need to remove the default ambient light we currently have in our scene. Create a world environment node and configure a world environment without ambient light or a skybox. Do this by creating a new environment inside the world environment properties. Set the background mode to a custom color of black and disable the ambient light source. Then we can start adding some lights to our entities. Give each light a different color, position, or range as you see fit. I am placing the lights directly above each entity, and I'm also giving the trees an extra large range to help illuminate the ground. Since this is an excessive amount of lighting, it is worth going into your project settings and altering some of the options in the lighting tab to use smaller and faster values. You can do the same in each light's properties. To improve performance, I am going to disable the bake mode of each light. If we hit play, we now have a colourful world with cyan-lit players, green trees, and bright orange cats. If you want to, you can adjust your online game dashboard map to show matching colours and icons for each entity by going into the Entity section of the game settings. To make some proper changes on the server side, beside aesthetics, we can download the Git repository containing the demo code from the URL on our game dashboard. To do this, search for a terminal or equivalent on your computer, then navigate to where you want to store your game using the command cd followed by the path to that folder. Once you're there, use the command git clone followed by your repository URL to duplicate the game's backend from the server. Then use the cd command again, followed by the name of your game folder to navigate the terminal inside of it. If we display this visually, we see the demo game repository will have a hidden.git folder for managing version history, an init.lua file, and another folder for entity Lua files. The name of each file in our entity folder corresponds directly to the entity types we used in each of our PP entity nodes. So our cat scene had the type cat to match the cat.lua file. We're going to make a small change to the tree entity's behavior to make them gravitate towards the center of the map. In the update function, get the tree's current position relative to 0, 0, 0. Invert it to get the position of the origin relative to the tree. Add a drag factor so that the tree will only gradually move towards the center. Then use the entity move function to apply that movement. Save those changes and then use the command git add-A to add all of your changes to staging. Staging gives you a chance to review your code before you proceed. So let's use the command git status to check we have all the correct files edited. Only the tree.lua file has changed, so it looks like we can safely record our change in our game's version history and log it with a memorable message using git commit-m. Now we just need to upload the changes from our clone back to the original repository using git push. For these changes to take effect, we need to use the deploy latest changes button to synchronize our game server with the changes that we made. Deploying the latest changes will automatically stop the game server for a brief time and then restart it. Our trees are now being slowly drawn into the center. If we look closely, we should be able to see the same effect in-game, especially if we time-lapse it. Our documentation has more details on how to start crafting your game world. To make more changes to your chunk and entity behavior, simply edit your cloned files however you wish, ensuring that the entities in your Godot project and the game repo always match. So if you create a new entity, make sure it has the Lua file and the respective scene. Thanks for watching this tutorial on how to integrate Godot with the Planetary Processing multiplayer engine. If you want to stay up to date on everything we do, or need help, check out our Discord.